Okay, so just a quick review of some of these ideas we've been talking about in terms of average and instantaneous rate of change. Let's look at an example where we're given the function negative x squared plus 1. We'll run through finding the average rate of change between 2 points, getting an equation of that line, finding the instantaneous rate of change at 2 points, and an equation for a tangent line at one of those points, and then draw a plot that has these points and these lines on them. So we'll begin by defining our, of course we import our libraries, and then we need to define this function, negative x squared plus 1. And to find the average rate of change between x equals negative 3 and x equals negative 1, we're going to find the slope of the line between those 2 points. The point negative 3 and whatever f at negative 3 is, which is negative 8. Again, because I have f defined here, I can just plug in x values and it will spit in, I'll get back the y values. And so the y value for when x is negative 1 is 0. And then I can just plug those values into my slope formula. So y2, 0, I'll let y2 be 0, minus y1, negative 8, over x2, negative 1, minus x1, negative 3, and we get a slope of 4. So the last part of this piece was to write the equation of the secant line through these 2 points. If we recall our point slope formula from class today, this comes from the slope equation, and all we'll do is we'll make some arbitrary x and y coordinates so that now we're just plugging in a slope and x and y. We'll take this point, negative 3, negative 8, and if we substitute that in, we get y minus negative 8. I can write that as y plus 8. The slope was 4, and x minus negative 3 is the same as x plus 3, so there's our equation for that line. Next question was instantaneous rate of change at x equals negative 5. So I can find this by substituting in negative 0.5, and then just like we did in class today, we can take another value very close to it, something like negative 0.5, 0, 0, 0, 0, 0, a bunch of zeros, and 1. And then we can find the slope of the line between these 2 points as an approximation for that. And so all I've done is copy and pasted these guys and popped them into the slope formula. Here's y2. I'll let that f of negative 0.5 be y2 minus y1, f negative 0.5 with a bunch of the zeros and 1 just to the right of it. And similarly the x coordinates, and we get a slope of 1 point with 3, 6, 7 zeros and then a 1. If I wanted to, I could check a point just this much to the left of to the other side, so a 0.49 with a bunch of 9s after it, and I imagine that what I would get is another number that's very close to 1. So there's our approximation for the instantaneous rate of change. It's going to be 1. I'm going to guess 1. The instantaneous rate of change at x equals positive a half, I just follow a similar path. I'm just going to change the x coordinates to 0.5 and make this one positive as well. So basically just make everything positive, and I get negative 1 back for the slope of that line. Finally, I was asked to write an equation for the tangent line at x equals 0.5. So I need a point and a slope. I have my slope as negative 1, and here's my point, x equals 0.5, y equals 0.75. So similarly, we'll use the same point slope format, and we get this equation, y equals negative 0.75 equal to negative 1 times x minus 0.5. Finally, I need to plot it all. So to plot it, I'm going to do this all in one figure. I need to define my x coordinates that I want to see in the plot. So I'll just go from -4 to 4, then I'll include all of these points. Remember, I had a -3 here, so just to make sure that I see everything. I'm going to define the tangent lines just as y1 and y2. So for this, to use this line in Python, I need to move this 8 over. So I have an equation for y explicitly in terms of x. And to do that, I would just subtract that 8. So that's where this equation came from. My y1 is just that equation of the tangent line with the plus 8 moved over to the other side. Similarly, the second tangent line, it comes from this equation. I just move this -0.075 over. So y1 and y2 are representative of the of tangent lines. Actually, this is the secant line, and this is a tangent line. So this should cut through the graph. This should cut through a point and just be tangent to the graph. Finally, I plot the function, plot that secant line, plot the tangent line. I'm also going to plot some points. So a point at where I'm drawing the tangent line, and points at where these are 2 points at where the secant line will go through. And this is maybe the first time that we're seeing, I can put multiple arguments into the plot function here. And finally, I'll add x and y axes just to make it look right. And there we go. Here's my tangent, right? It just touches at this one point. And here's my secant line that goes through those 2 points. If I wanted to, I can actually even zoom in on this piece here, and you see that that line, even though it's spaced apart, it's barely going through any of the other points. It's supposed to just touch at this point and go right through. So, okay, that's it. That's it.